Alright, so this LeetCode question is called valid palindrome. It says given a string, determine if it is a palindrome, considering only alphanumeric characters and ignoring cases. Note, for the purpose of this problem, we define empty string as a valid palindrome. Alright, so remember that a palindrome is just something that reads the same forward and backwards. And what they're saying is that if it's anything but a letter or a number, we have to ignore that. And also, we don't care whether the letter is uppercase or lowercase. All right, so example 1, a man, a plan, a canal, Panama, is a valid palindrome because if you read it forwards and backwards, it's the same. And example 2, race a car is false. For the same reason, it's not the same forwards as backwards. All right, so the key to solving this problem is to use two different pointers. And by pointer, I don't mean actual pointers like in C++. I just mean references to two different elements at once. All right, so what you need to do is you need to put one pointer in the first character, we'll call that P1, and we'll use another pointer to reference the last character. And what you're going to do is you're basically just going to check to see if these characters are valid and if they match. And if they do, you're going to one by one move pointer 1 to the middle and pointer 2 also to the middle until they're the same character. If at any point they're not the same, we can just return right there because we know at that point that it's not a valid palindrome. All right, so is the letter at P1 a valid character? Meaning, is it a letter or a number? Yes, it is. Is the character at pointer 2 a valid character? Yes, it is. So now you compare the two. Are they the same? Remember, we're ignoring case, so it doesn't matter whether it's uppercase or lowercase. So yes, M is the same as M. So now what you do is you move P1, 1 to the right, and P2, 1 to the left. Now we do the same comparison. Is the letter at P1 a valid character? Yes. Is the letter at P2 a valid character? Yes. Are they the same when you ignore case? Yes. So now we just move P1 and P2 to the middle again. So P2 goes this way, and P1 goes this way. So now, is the letter at P2 a valid character? Yes. Is the letter at P1 a valid character? It's not, it's a space. So now we have to move P1 again. So now that P1 and P2 have met, we know that this is a valid palindrome. All right, so let's use the same logic with an example that's not a valid palindrome. So we'll start with P1 pointing to the first character and P2 pointing to the last character. Is each character valid? Yes. Do they match? Yes. So you move them in one. Is each character valid? Yes. Do they match? Yes. So we move them in one again. Is each character valid? Yes. Do they match? Yes. Move them in one again. Is P1 valid? Yes. Is P2 valid? No. So now you keep moving it until it is at a valid character. All right, is that a valid character? Yes. So now you compare the two letters. Is E the same as A? No. So this is not a valid palindrome. All right, so let's get to the code. What LeetCode has given us is a function called isPalindrome, and it accepts S, which is the string that we're going to check whether or not it's a palindrome. So remember, the first thing we have to do is make two pointers, one starting at the front of the string and one starting at the end of the string. So we'll say let pointer 1 equals 0. So that would put us here. And then let pointer 2 equal s.length minus 1. So that would put us here. All right, so now we have to loop over the string. So we'll say while pointer 1 is less than pointer 2, meaning if pointer 1 ever gets to the halfway point, which would be in this case here, then we're done. All right? Now inside of this while loop, we'll need 2 more while loops. And what these while loops do is check whether the pointer is on a valid character. If it's not a valid character, the while loop continues until it finds a valid character. So we'll start with the first one. While it isn't a valid character, and by the way, this is valid character function we haven't created yet. We'll do that at the end, but for now, just know it checks whether or not the character is valid. So if it's not a valid character, car at pointer 1, what do? We increase pointer 1 to the next character. Remember, this keeps going on until it finds a valid character. Second while loop does the same thing except for pointer 2. It checks to see whether or not pointer 2 is on a valid character. If it's not, it decrements pointer 2 until it finds one. So is valid character s.character at pointer 2 we decrement pointer 2. All right, so a quick example. Let's say pointer 1 is here, which is on a space. It's going to say, well, that's not a valid character. So then it's just going to move here to the letter P, which is valid. So now that the pointers are at valid characters, what do? We have to check and make sure those characters are equal. So we'll say s.car at pointer 1. What we're doing is we're going to check to see if they're not equal. And if they're not equal, we return false. Because in a palindrome, every mirror element has to be the same. So if the character at pointer 1 doesn't equal the character at pointer 2, then we just return false because we know it's not a palindrome. And one more thing to remember is that we don't know what case the characters are in. They could be uppercase or lowercase. So what we have to do is we have to come up with a way to make the characters the same case so that we can compare the two. So let's say we're comparing the letter A capitalized to the letter A lowercase. If you just did a straight comparison, it would be false. But that's not what we want. We want to be able to ignore the case. So what we're going to do is we're going to make each of those lowercase. So s.character1 dot to lowercase. So we're making the character pointer 1 lowercase so that we can compare it to the character pointer 2, which is also going to be in lowercase. So if we make it to this step of the code, it means that the two characters were equal. So what's the next step? We have to increment pointer 1 and decrement pointer 2. That would look like this. Move this here and move this here. Okay, so before we move into the implementation of the isValid character that I've referenced a couple times, let's go through this entire loop. So let's start at the top. In this outer loop, there is that inner loop. And what that inner loop does is checks whether the character at pointer 1 is valid. If you look, the character at pointer 1 is an empty space. So that inner loop is now going to increment 1 and put pointer 1 here. Now it's going to check again. Is this a valid character? Yes, it is. So now we go to the next while loop that looks at pointer 2. Is this a valid character? Yes, it's the letter M. So we're good. So now it goes to the if statement and checks whether those two elements are the same. when we make both of them lowercase? Yes, they are. So now we can increment pointer 1 and decrement pointer 2. All right, let me speed through the rest of this so this video doesn't last like 45 minutes. Is C a valid character? Yes. So we move to pointer 2, decrement this by 1. Here is C a valid character? Yes. So now we compare them. Does C equal C? Yes. So then pointer 2 goes here, and pointer 1 goes here, pointing to the A. So now we look at the condition for the outer while loop. Is pointer 1 less than pointer 2? No, they've crossed paths, so now pointer 2 is less than pointer 1. So now it breaks out of the loop. And since we've gone through all of those and it's broken out of the loop, it means that we do have a valid palindrome. So then we need a line down here saying return true. All right, so now I'll just quickly implement the isValidCharacter method that we've referenced a couple times. So let isValidCharacter equal a function which takes in a character. All right, so the way I'm going to do this is actually not very efficient, but it works. I'm sure there are better ways. The way I'll do it is I'll have a variable that has every letter from A to Z and every number from 0 to 9. So basically, whenever a letter or number is passed in, it's going to check against that variable to see if the character is in that variable. So let's say the number 3 is passed in. Since my variable is going to have the number 3 in it, it's going to say, yes, that is a valid character. So we'll say, let valid characters equals okay, so that's a list of all the valid characters. So now I'll just check whether the character passed in is anywhere in my valid character string. So we're going to return valid characters dot index of character to lowercase. And we're using to lowercase just in case an uppercase letter was passed in. We'll just make it lowercase so we can compare it to all the lowercase letters in the valid chars string. All right, and we check to see if that is greater than -1. Because in JavaScript, if a character is not in the string, index of will return -1. So we know that if it returns a value greater than that, it means it has found the string. All right, so that's that. So all there's left to do is check it. Okay, looks good, and now we'll submit. All right, and we'll check out our results. Our solution was faster than about 22% of other JavaScript online submissions. I'm guessing that must be because of our inefficient isValidCharacter function, but at least we know it works. So as usual, the code and written description are linked down below. See you next time.